All right, guys, here's my sample problem number 4 that will be similar to your number 4 problem on Module 4 assessment problems. Mine says, given the equation 4x plus 7y equal negative 12, write a second linear equation to create a system that, part A, has exactly one solution. Explain. All right, there's a couple of things that we can think about when we're trying to figure this one out. One recommendation I have for you is to take your equation and rewrite that so it's in slope-intercept form. What that means is I want to have the y variable isolated. So for my equation, I'm going to show you how to do that right now. The 4x plus 7y equal negative 12. First step I'm going to do is eliminate this x term. I have to combine the opposite of this x term to do that, which would be a negative 4x. And remember, if I do that on the left side of the equation, I got to do the same operation on the right side. So I'll put an equal sign, and I'll put a negative 4x over here. So then that leaves me with the 7y term on the left side. So bring that down. I recopy it, and I have 7y then equal the negative 4x. And bring down that minus 12. Now remember, you can't combine those two terms because this is a variable term and the negative 12 is a constant term. Now my last step to get this equation in slope-intercept form is to get rid of this coefficient of 7. 7y means 7 times y. So to eliminate the 7, I need to divide by the 7. And if I do that division by 7 on the left side, I have to divide all my terms on the right side by 7. So you see I'm doing that to the x term into the constant term. Now when I do that, then the 7 divided by 7 on this left side is 1. 1 times y is y. So I end up with a y equal the negative 4 sevenths x minus 12 sevenths. And I'm just going to write that a little bit nicer up here so you can see it. So I have y equal the negative 4 sevenths x minus 12 sevenths. All right, so that's in slope-intercept form now. Now that allows us to have a little bit easier equation to use as a reference when we're going to answer these questions. So on question A, if it has one solution, right, that means that you want an equation that's going to be, if you were to graph it, intersecting this equation right here, if you were to graph that. So all you need to do is write an equation that has a different slope than this one and a different y-intercept. So there's many options for you. So one option you could write for this one would just be y equal 5x plus 6. Now remember, there's infinitely many solutions. I'm just telling you to answer question A, you need to write an equation that has a different slope than this one and a different y-intercept. All right, so now let's go to question B. It says, has no solution, right? So think about this if you were graphing. If it had no solution, you'd see two lines on your graph that would be parallel. They would never intersect, right? Because the solution is that point of intersection. That's the one point with an x number and a y number that would work in both equations. So if there's not a solution and there's no point of intersection, we need an equation that has the same slope as this reference, all right, but it has a different y-intercept. So for example, I could write here y equal negative 4 sevenths x plus 9. Now what that does, right, if we were going to graph this, I would start the graph of this equation, my y-intercept positive 9, right? And then the slope is negative 4 over 7, so my vertical change is the negative 4. I would go down 4 units and then to the right 7, down 4 over 7. Now when I graph this one, I'm starting it at a different location on the y-axis. I'd start this one at negative 12 sevenths. So because I have a different starting point, when I go down 4 and over 7 with the slope, you can see that they would never intersect. So when you're answering your question B, you just want to make sure that for part B, when it has no solution, you have an equation with the same slope, different y-intercept than your reference one. Now question C, it says has infinitely many solutions. So here we want an equation, right, that just has a slope, and a y-intercept that is a multiple of your reference one. So whatever you want to multiply your reference equation by, make sure you multiply the y term, the x term, and the constant term by the same number. So for me, all I'm going to do on my reference one, y equal negative 4/7 x plus, or sorry, scratch that. It's the y equal the negative 4/7 x minus 12/7. I'm just going to multiply that whole thing by 2, and I'm going to show that to you right here. So if I take 2 times y, I have 2y, right? My equal sign. Then 2 times negative 4/7 is going to give me negative 8/7 x. And then 2 times this constant term here is going to give me negative 24/7. So if I were to graph those, I would end up graphing identical lines because this equation I just created can simplify down to my reference one. So on your question C, all you need to do is take that reference equation and multiply each term in it by the same number to create another equation that will give you infinitely many solutions. All right, hopefully that's helpful. Now on this last question, part D here, it says interpret the meaning of the solution if it exists in the context of the graph of the following system of equations. My first equation is negative 3x plus 4y equal 9. My second one is 9x minus 12y equal negative 27. Now what I want you to notice here when you're comparing these, I would want you to compare your x term negative 3x to the 9x and see if you can figure out what they multiplied the negative 3x by to create 9x. Hopefully you would say negative 3 because, right, negative 3 times negative 3 is positive 9. Then check that negative 3 with the 4y and see what happens with that. If we take 4y times negative 3, I get negative 12y. And then check the 9 and multiply that by the negative 3. 9 times the negative 3 gives me negative 27. So what you can see here is if you take this equation, multiply it, right, by the negative 3, you are going to get the second equation. And we know then that when that happens, that if we were to create a graph, the graphs here would be the exact same line. So therefore, when we are going to talk about the solution in the context here, the solution would be infinitely many solutions, because any solution, any ordered pair that would work in this equation is also going to work in this second equation here. All right, guys, hopefully that helps you. Have a good one.